So in this video, we're going to look at example 6. Consider the sequence of triangles in the figure which shows the beginning stages of a geometric construction called Sierpinski's triangle. The figure begins with an equilateral triangle, stage 0, divided into 4 smaller congruent equilateral triangles, and then removes the center triangle, stage 1. This process is then repeated on the smaller triangles to get stage 2. If this process is continued to stage 10, how many different green triangles would there be? So, again, here we start with this equilateral triangle, stage 0, and then to move to stage 1, we divide stage 0 into 4 equilateral triangles and we remove the center. So it's the same triangle that we started in with stage 0, except we've removed that center triangle after we've divided it. And then as we move to stage 2, we take each of the 3 green triangles that we have here and we divide them into equilateral triangles and remove the center. So again, we've removed the center here, we've removed the center here, and we've removed the center here. So for stage 3, if I try to do stage 3 here, so this would be shaded, this would be shaded, and so on. This would be stage 1. But then for stage 2, we have divided these like this. So this is stage 2. This would be shaded green, 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 green. And again, now for stage 3, I would divide each one of these green triangles into 4 and remove the center. So this would get divided into 4 and we would remove the center. So in stage 3, this triangle would be shaded, this would be shaded, this would be shaded. Again, this one would be divided, this would be shaded, this would be shaded, this would be shaded, this would be divided, shaded, 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 shaded. And then this one would also be divided and shaded, 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 and shaded, 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 and shaded, shaded, shaded. So this is stage 3. So if we take a look at this pattern, what's going on here, we're starting off with 1 triangle, and then we have 3 green triangles. And if we count here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 green triangles. Stage 3, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. We have 27 shaded triangles here. And if we were to continue, then we would continue to form the same kind of pattern. So let's take a look at what's going on here. So we started with 1, then we had 3, then we had 9, then we had 27. So what we can see is that each time that we divide and go to the next stage, we're ending up with 3 times as many triangles as we had in the previous stage. So for example, stage 4 is going to be 3 times 27. Stage 5 is going to be 3 times that, and so on. But would we be able to find maybe even a little quicker pattern, so to speak, or formula for that? Well, these are powers of 3. So for example, 1 is equal to 3 to the 0 power. 3 is equal to 3 to the first power. 9 is equal to 3 to the second power. 27 is equal to 3 to the third power, and so on. So when it's stage 0, I have 3 to the 0 power. When it's stage 1, I have 3 to the 1 power. When it's stage 2, I have 3 squared. When it's stage 3, I have 3 to the third power. So if I want to get to stage 10, I wouldn't want to have to actually draw this thing. It was challenging enough to just sketch this stage 3 triangle. But if I continued to stage 10, then the number of shaded or green triangles would be 3 to the 10th power. So what is 3 to the 10th power? Well, if I bring in my calculator, 3 raised to the 10th power is 59,049. So if we were to continue this pattern to stage 10, there would be 59,049 different triangles that would be shaded in green. So again, this is a counting method. Our counting method in this case is that we determined a pattern of how we were going from one stage to the next. And so this is an effective method for counting. So this concludes our examples for section 12.1. You should now be able to do the section 12.1 homework assignment.